All right, we'll go ahead and get started. Hey, hello, good afternoon, everyone, and a very warm welcome to this year's Trailhead DX Salesforce Developer Conference. Now, Trailhead DX is our developer-centric conference. We focus on the latest and greatest at Salesforce to make your lives much easier. What I want for you is to attend this session and take away from it so that you can go back to your customers and build the most compelling and delightful apps for them. Personally, this is my third Trailhead DX, and every time I'm always excited because I get to engage with all of you to listen to the things that you want us to build for you to help make your development lifestyle much easier. So my name is Nick Chen. I'm a principal engineer and product owner on the Platform DevTools team. Joining me on stage today is Jonathan Ijaja. He's a senior engineer on the same team. Now, our team is in charge of building tooling for the platform. You may be familiar with some of our offerings, like the Developer Console, the Force.com IDE, which is soon to be replaced by our Salesforce DX extensions for Visual Studio Code. We'll talk more about that. The Apex language server, and of course, the Apex debugger. Today, we're going to talk about the Apex debugger and how you can use it effectively to banish your bugs. Now, if you're paying attention to the slides, you'll notice that we have deliberately used the term Apex Debuggers. So it's a plural one because you're in for a treat today. We're not going to show you just one. We'll show you two debuggers, all right? Now, with that being said, the first slide that I have to show you is, of course, our forward-looking statements. Lots of text there, don't worry. What it means is that if you're making any purchasing decisions, please base them on products that we already have available today. We'll be showing you a lot of things that are yet to be available. They are very, very exciting, but they're coming soon. All right, now with that out of the way, let's get started. And if you notice our title, there are two main keywords, Apex and debugger. So I want to focus on Apex first. How many in the audience have heard and used Apex? All right, wonderful, you're the right session. All right, some things about Apex is that it's been available since winter 2007. It's an object-oriented and trigger language for Salesforce. It takes a lot of features from Java, C#, and PL SQL. So if you're familiar with any of those languages, this will feel really at home for you. Apex is very powerful. You can do anything and everything, right? We'll show examples of that there. And it also offers seamless integration. So if you're using Lightning, you're using Visualforce, you're using Flow, you can always complement that with more power from Apex itself. Now that I've introduced Apex, let's give some real stats about how prevalent Apex actually is. We have over 700 million lines of Apex code in production today. We have over 40 billion Apex transactions per month. And of this, and we're counting really, really conservatively, tens of millions of users, distinct users, interact directly with Apex. So you can see just how prevalent Apex really is. And it's going to continue to grow. And as part of that, we are the tooling team. So we want to provide you with the tools that help you work effectively with Apex. And we have three main categories where we're providing tooling for this. The first one is with coding. Last year at Dreamforce, I gave a talk about the language server protocol. How many of you managed to attend that session? All right, we've got a few there. The good news is it's recorded, so if you want to go and see it, you can go online and search on it on YouTube. In a nutshell, I introduced the language server protocol and how we're committed to it. What it means is that we have a way, in an IDE-agnostic manner, to provide you code completion and code navigation. In that demo, I showed in 40 minutes how you can provide code completion and code navigation in Visual Studio Code and also the Atom editor. So all of this is really done in an open manner. Next thing we have is, of course, testing. Testing is an integral part of working with Salesforce and with Apex. We show you how you can run unit tests and integration tests along with code coverage metrics to increase your confidence. And last but not least, of course, debugging. It's also another very, very essential step in actually doing your lifecycle development. So you know we have the interactive debugger. These are also built using the debugger protocol, which is an IDE-agnostic way to build debuggers. So you can use this today in Visual Studio Code. There will be commitments from other IDEs on how you're going to do this. For the first time today, we'll be introducing the replay debugger. All right. So all of this is bundled really, really nicely in our Salesforce extensions for Visual Studio Code. And if you look here, this is actually available. This is a very simple URL, so it makes it easy for you to copy it. But all of this is being developed in an open source manner on GitHub. That means you can go in, raise issues, or ask for feature requests, and we've been actively engaging with customers. In fact, just today, someone was asking me about a question about the Apex formatter, and we talked on GitHub just to make sure we know when we're going to provide that. Okay, so a lot of talking. What we like to do throughout the session is actually drive it through demos. So I'm going to show you how we can build a simple bot with Apex and Lightning. And based on the theme here, what I'd like you to imagine is like we're going on a safari trip, and what's going to happen is maybe, just maybe, we'll see 1 or 2 bugs, and we'll show you how to use those debuggers to squash them. And by the way, this may be one of the few sessions where people are sort of delightful to see bugs and how we can actually use them. All right, with that, I'd actually like to call Jonathan Vijaja on stage to show us the app that he's built. So while he's getting set up, I'm actually going to talk a bit about the app. The app that's going to be shown is actually the Dreamhouse app. We've been using that continuously throughout many TrailheadDX conferences and also Dreamforce conferences. In a nutshell, it's a property management app that lets you scroll through properties. And it's an amalgamation of all the different technologies that you can actually use on Salesforce. It's open source. It's also on GitHub. So if you want to check it out, see all the nice things that we have, go for it. Today, what we'd like to do is actually have Jonathan, who actually worked on one of the features on Dreamhouse, to actually show us this new feature. So Jonathan, take it away.
All right. One of the features of the Dreamhouse app is a personal assistant called DreamBot. It's a tool built on the Lightning platform with an Apex backend. You can ask it for help on various real estate topics. So for example, we can find a house in Boston, and I'm going to choose single family with a price range from $100,000 to $1 million. It gives us a list of properties. The results here are fictitious, but we can click on one of them to get more detailed information about that property. It's a pretty cool tool. Want to check it out, Nick?
All right, let me do that. So I'm going to put on my product owner hat right now and give this a try. All right. So this is really nifty. I like it, Jonathan. So thank you for the team for building this. I'm just going to repeat what I did, which was typing in find house. And, well, I like Boston, so I'll put in Boston as well. And single family sounds good. Price range, let's do 100,000. And we'll also do 1 million. And, oh, it looks like we found our first bug for today.
That does look like a bug.
Just within a few seconds of it. All right. Before I talk more about bugs, how many of you actually know the etymology of the word bug? We've been using it. Excellent. So I tried to go on Wikipedia just to find out, and you can fact check me. I think the term came about when in 1880, Thomas Edison actually coined this term. But the most famous story that I actually like to share is actually this one, because it's very, very interesting. This here is actually a moth. And so this is figuratively and literally a bug. This happened in the computer over at relay number 1770, panel F of the Mark II Aiken relay calculator, while it was being tested at Harvard University 9 September 1947. So for people who grew up in the modern age where computers are slick like that, computers never used to be that way. They were the size of this room, perhaps even bigger, and they were the size of cabinets. And it was very, very easy for a bug, in this case this moth, to get trapped between the relays, actually short-circuited, and this is where you have the bug. And this is sort of the most famous retelling of it. It comes from Grace Hopper, who was actually famous for the Grace Hopper Conference, among other things. She's also one of the first computer scientists in the world. So just wanted to point out. A bit of tidbit about bugs, just so that we know that. So this is the bug, and what I'd like to do is show you our journey for today, right? What we want to do is see, and of course Astro is popping up there to help guide us through here, how we could use the debugger to effectively debug around this. So to me, the application lifecycle consists of planning, coding, debugging, testing, and releasing. Of course, this is just a small piece of the bigger puzzle. If you're familiar with Salesforce DX, this is actually the center of how we develop software. If you're not familiar with Salesforce DX, don't worry, I'm going to give pointers to different sessions that you can attend. We also have a booth going on that corner there, so you can come and ask us questions. But for today, we're going to focus on the IDEs, the text editors, and the language services. And I'm going to do 3 things. First, I'm going to show you how you can actually write code in a testable manner. And for that, I'm actually going to show you the Apex code editor in Visual Studio Code and the features that it provides. Then I'm going to show you how you can use the debuggers available to you to debug effectively. And we'll show this first with the interactive debugger, followed by the replay debugger. And last but not least, we place great importance on testing. So I'm going to show you how you can easily use some of the tools we have to write tests after you fix the bug so that you can actually prevent future regressions. Right? So speaking of debuggers, I also want to give you a timeline of debuggers that have been available to Salesforce. Right? When I started at Salesforce about 2013, the first thing that we had was actually the developer console. My colleagues built this in 2011. It had the first sort of log viewer going on there. And then in 2015, in the Force.com IDE, we introduced the world's first multi-tenant Apex debugger. This is the starting point for the interactive debugger. Then last year, we pivoted over to Visual Studio Code, and we have the same interactive debugger now in Visual Studio Code. And for the first time in 2018, all of you are seeing this replay debugger for the first time here. Now, it won't be fair to say that we're the first to invent the concept of a replay debugger. The idea of this has actually been going on through other industries. So I want to give people credit for this. All our tooling vendors, and I know a few of them actually in the crowd today, have also contributed to this. The earliest implementation that I know of was around 2013 by Brain Engine. This company is no longer around, but they have a very nifty replay debugger. And then, oops, skip the slide there. So, and then we also have Illuminated Cloud. I know Scott Wells is actually here. And, whoa, this keeps doing this. I apologize. Let's do this again. So Brain Engine, Illuminated Cloud, Welkin Suite, all right? All of them have different offerings of the replay debugger as well. In Illuminated Cloud, it's called the Apex Offline Debugger. In Welkin Suite, it's called Apex Retrospective Debugger. All of them do the same thing. They're all built using the same underlying mechanism. The good news about this is that since we are all using the same underlying mechanisms, any changes that Salesforce makes immediately benefits the other IDEs as well. Why am I making a big deal about this? Because Salesforce DX is about using the tools that you know and love. I'm not going to compel you to use this particular IDE, right? We want to make it possible so that you can use the IDEs that you like, okay? Of course, I would like to invite you to try out our IDEs as well to see how do you like it. All right, now let's go on to this one. So, how does DreamBot work? Throughout this talk, I'll also be sprinkling tidbits on how you can debug effectively. And the first thing you need to know about debugging effectively is that you never go in blind. You need to have a high-level understanding, at least, of the context of your application. So let's decompose the DreamBot app into simple, understandable chunks, which will help you as we're using the interactive debugger. So the first thing is that you realize that DreamBot works this way. There is a client component, as you can see on the left-hand side of the screen, and there's a corresponding server component on the right-hand side of the screen. The DreamBot app is actually powered by a Lightning component underneath it. This Lightning component is called bot component, and it makes an Aura action call over to the server. Now, on the server side, this is where Apex actually lives. The first thing that gets hit is actually the bot controller class. What happens here is that the bot controller listens to what you have typed and delegates over to the appropriate bot handler. So bot handler is actually an interface. And what this does is that you have different implementers of that interface. So on this side, we have the help, the find properties, and the circle. And of course, we have a few more other ones that you'll see throughout there. So as for our use case, we know there was a bug with FindHouse. FindHouse is actually handled by the handler find properties class. So this delegates over there. All right, so these are the three main classes that we have to keep at the back of our head throughout this presentation: the bot controller, the bot handler, and the handler find properties. All right, so now with that out of the way, let me switch over to show you how we can use the Apex Interactive Debugger. Okay, so we have this over here, and what I'm going to do is I'm going to drag this over to Visual Studio Code on this side so that we get a very nice view of debugging side by side. I'm going to give a bit more space over here. So talking about Visual Studio Code, how many in the room have actually heard of it or used it before? All right, good. So some of you may not be familiar with it. Let me summarize. It shares the same Visual Studio moniker as the big Visual Studio Professional Edition. It's a slightly different application. It started out as an open source project on GitHub, and it runs natively on your Mac, Linux, and Windows. And the important thing is that this is the free version of it, right? You don't have to pay a single cent for Visual Studio Code. Now, what we have done at Salesforce is that we have augmented Visual Studio Code, which is a simple code editor that's really, really powerful with extensions. So if I click over here, you can see the things that are available over in the Visual Studio Code marketplace that we at Salesforce have actually committed to. So you see the code editor, the debugger, the replay debugger, and so on and so forth. All right. So what I'm going to do today is actually start debugging this first, and I'm going to drive this. The first thing you have to do is switch over to the debugger view over here, as you can see. All right. And I'm going to launch my Apex debugger. What this does is that it launches a session that is persistent to the actual server there. And you can see that it's actually connected by this little panel here. So this is the panel allows you to step in, step out, stop debugging session. Now that I have my debugger connected, what I'm going to do is actually set breakpoints. So I know that the main class that I was talking about is actually my bot controller. So let's go ahead and open that. And over here, you can see this is the submit. So I'll just hide most of this so you can see this. This is the submit method, which will handle all the interactions as it's coming through. I'm going to set breakpoints at this handler handle over here, and one more here as well. And of course, we know just now that it says, oops, something went wrong invoking that command, right? And you can see here, this is the other one. So I'm going to set a breakpoint over here as well, so that we can capture exactly where the problem is. All right, now that I've set up my debugger on the left-hand side of my screen, I can come here and I can invoke my command. So as I type find house, you notice that it's not replying immediately because it's now paused directly on the debugger. So we are debugging this live, and this is really, really powerful. So if you come here, you notice that it's hit one of my breakpoints. Let me showcase, as we're talking about this, some of the useful features of the Apex code editor. So if you come over here, this is bot handler. If I right-click here, I can actually use find all references to find all the implementers of the bot handler class. And this is really, really useful because it shows you all the different implementers. As we've discussed, you have something for handler help topic, handler next, pipeline, quarter, circle. So everything is nice in this pick view that you can actually see. And this is powered by Apex language server. So now let me close this, and let me use and jump into my handler handle method. So if I jump here, it's going to go over to a different file, which is my handler find properties file. And in this case, I can actually step through and go through all of this. Now, one thing that's useful is that it's not just stepping through. If I show the left-hand side of the panel, you notice that we also have our variables view, which you see with any other debugger that you've used before, and also the call stack. So this is a very useful way to keep track of where you are as you're debugging. All right, so I'm just going to go through here and stepping through. And as I go through this, you'll notice in a bit, it's going to respond, and it's going to give me the response here. And it's going to ask what city. Now, I'm going to cheat a bit, because I know that the bug usually happens at the last step, which is where it's asking for the max price. So I'll put a breakpoint here so that we don't have to go through this process of stepping through. And then I'm actually going to remove my breakpoints here, because we already know how this program actually flows. All right. So let me continue, and I'm going to type in Boston. Oops. That's fine. We use this. And price range, I'm actually going to put in 100,000. I'll do price range to 1 million. So I do this, it's going to pause in my debugger, and I can go in and see what's going on. At this point, I don't actually know where the bug is, right? So I'm just stepping through, I'm exploring and trying to figure out where the problem is. As I'm going through this, goes through, things should be copacetic, but it comes in over here and it says, but I don't know how to actually answer that, all right? So if I step through more, realize that we go into this that's capturing exception. I go over here, and I can use this to see, oh, this looks like a system type exception, invalid decimal of 1 million. So I must have done something wrong there. So at least at this point, I have a hypothesis of what's going on. So as you're debugging, one of the main things that you have to do is constantly talk to yourself or talk to someone else. This is called bouncing off the wall, or forming hypotheses and trying to validate whether something is true or not. So let me just continue now. And I'm actually going to go ahead and set my breakpoint over here again and repeat the process. So I'll step through this more carefully, this time with the assistance of Jonathan. Right? So I come here, and I can say find house. One moment. Our caps lock key is actually stuck here, so this may cause a bit of problem. We will see. Jonathan, will you be able to assist me here?
Okay, it's off now.
Thank you. This was not intentional. This is real. So we do find house, and I'll type in Boston. I will do single family. I'll do 100,000. I'll do 1 million. All right, we'll stop at this breakpoint over here. As we go through, Jonathan is going to help me look at the variables view to see if something weird is going on here. Okay, no errors yet so far.
I think I do see something.
Oh, okay.
If you look at the
Obviously, he's more observant than I am.
utterance, there's
Okay.
a space at the end there.
Oh, dear. This is how I like to type. Sometimes I put space at the end of stuff, and this just blows up the whole thing. All right, so at least we know the problem, and I think you know how to fix this. What do you suggest that we do?
We could try trim.
Trim? Excellent. I really love this audience. I really. All right. So we have this. I'm going to actually stop the debugging session over here so we can proceed to fix this. I know people have been shouting out we can do trim and stuff, but this is a deliberate demo, so what I'm going to suggest is we actually write a test first so that we can reproduce this problem. Because what you've noticed over here is that as I'm typing, I have to go over to the right-hand side of my screen and type this over and over and over again. It would be much nicer if we can codify this in a test, all right? So this thing is actually predictable. It's not an error because what happens if I forcibly terminated that transaction over there when I ended my debugging session. So over here, I'm going to flip over to my bot test. All right, I'll hide this so you can see more. I'm doing something that's not really good practice. I'm going to copy and paste this to save time. If you want, please abstract this into a different method. And what I'm going to do is I'm going to say test find properties with spaces. All right? So what I'm going to do here is I'm actually going to add in spaces. Is this font size good? Can people see it? All right, excellent. So now I've made changes locally. I need to push it over to my org. And if you see here, this is another feature of Visual Studio Code. We've put in all the nice commands over there so you can filter in by SFDX. Okay? The one I'm going to do is actually push source to default scratch shot. So going over there, I'm going to push it. And once it's done, I'm actually going to run the test, and the way we can run this is with this new nifty command here. You notice this is actually called a code lens, and it's something that's intrinsic to Visual Studio Code. It lets you go ahead and run that test. So I'm going to run my test, and before people say something's going to go wrong, notice that this is deliberate. The test will fail because we know we have not fixed the code yet, right? And true enough, run apex test failed to run. Now, this is an opportunity for me to show you why I really want to do this. Because as I'm running this test, if I had written the test case first in a test-driven manner, I would have caught this problem. And not only will I have caught the problem, you'll see here that it will tell me precisely where it happens. So I can command-click here, and it will bring me to the line where the problem is. So this is much, much easier than trying to go and repeat those steps, right? Writing the test case first. OK, so now that we have a test case set up, we can go ahead and fix it. So I'm going to go to handler find properties, and I know people are already shouting out the answer there. So I can go ahead and do trim. And notice that I also have code completion here, which is aware of what's going on, right? It knows that session, in fact, let me show you this. If I command-click here, it will bring me to the definition of session. It knows that session is a map of string to string. So if I get something out of it, it must be a string, and therefore at the end when I trim is actually available on that particular string, okay? I'm going to do it the same for all of them because I tend to make mistakes and put trim on, put white spaces over there. So let's go ahead and fix this over here and push the code. All right. Now going back to my test should pass now, as it should. Wonderful. So you can see here, I know that my test has passed. Jonathan, I think we can call it a day. We solved the bug. What do you think?
I think you should also verify in the app itself.
This is a good
suggestion. That's what I would do first.
So actually, what I'm going to do is actually invite Jonathan to verify it. And Jonathan, why don't you get set up? I'll tell you a bit why we do this. And this is what we do at Salesforce itself. We always ask a different person to QA, to do the QA for it, because a different set of eyes always brings a fresh perspective to it. All right, so this is another tidbit if people are not familiar with it. I see a lot nodding around the audience. So I think I may be preaching to the choir here, but I just want to make sure we have a compelling and synergistic story. So Jonathan, why don't you go ahead and verify that?
Okay, I'm going to run through the scenario again. We'll find a house.
There you go.
In Boston. A single-family home with a price range from $100,000 to $1 million, with a space at the end.
So it's repeating my weird style of typing. And we got our results back. OK, I feel pretty confident now that we have actually fixed the bug. Not only have we fixed it, we have added a test case to prevent future regressions. All right, so let me go back over to my slides. OK, so what we just did was actually show you how we can use the Apex Interactive Debugger. So the Apex Interactive Debugger is very powerful for interactive and exploratory use cases where you're not really certain where the bug is yet and you can go in and explore stuff. It's available for free for all unlimited and performance editions. So if you're an unlimited or performance edition, you already can use this. If you are an ISV, you can also use this for free while you're debugging inside your subscriber sandboxes. Okay? This is also a good time to mention that this runs in sandbox and Scratchshot instances. So one question that comes up is, of course, what happens in production? And this is where the Apex Replay Debugger is really, really important. The Apex Replay Debugger will work in production, sandbox, and Scratchshots, right? It's universal. We'll get to see how this works. It uses the Apex debug logs that you're already familiar with. It's a recording of all the interactions in a transaction. It captures which methods are entered, which statements are executed, and which variables are actually assigned to. So the Replay Debugger does this and presents this information nicely. So over the next few slides, I'll just codify this a bit more and show you how it works behind the scenes. So if you come over here, this is Visual Studio Code. On the left-hand side of my screen, I have a very simple Apex class. It's just called sample. It has one method, which is run. And the text in green, which is in comments, is actually what I'm going to do when I do an Apex execute anonymous. As I execute this, what's going to happen is that it's going to generate the log on the right-hand side of the screen. Right? There's a lot to pass through, and for this particular segment, what I'm going to do is just simplify this a bit so that we can actually see the gist of what matters. This is the part that we're interested in. Right? I've made it simple, but the concept will still be there. As I execute my program on the left-hand side of the screen with a sample run, it's going to execute it on the Apex runtime. So it steps through and goes to the first line of code. And what this does is that it generates on the server side 3 entries on the Apex debug log. In this case, you can see it's doing a method entry and a statement execute. As I execute to the next statement, it admits 3 more entries into the debug logs, right? So it says statement execute, a variable scope begin, and a variable assignment, and so on and so forth. So as you can gather from here, this is actually a very, very high-fidelity recording of everything that's going on. And this is what enables us to actually use this to replay things as they're going on, all right? So this is the power of it. What I've shown you is things driven from the left-hand side that generate stuff on the right-hand side. But the converse holds true. You can use the right-hand side to actually simulate what happens on the left-hand side. And that's the key idea of the Apex Replay Debugger. And of course, talking is good, but seeing a demo would be much better. And for that, I'd like to invite Jonathan again to show us how we can use the Apex Replay Debugger. What he's going to do is actually show us how he could use the Replay Debugger to sort of debug the case that we just fixed earlier. All right, Jonathan, take it away.
All right, so you've seen the Apex Interactive Debugger. Let's see how the Replay Debugger can help us fix the same bug. The Replay Debugger depends on debug logs. So I'm going to turn on logging first. We can see from the output at the bottom that we're enabling logging with the finest granularity, so any action I do in the app will be captured in a log. Next, I can go back to DreamBot and run through the same scenario again. We'll find a house in Boston, single-family home, with a price range from $100,000 to $1 million with a space at the end. We don't see any errors here because we just fixed the bug, but that's okay. We just want to get the debug log for the scenario. And we can do that from VS Code by using this convenient command, get Apex debug logs. So this will query all of my logs, ordered from most to least recent. So I'm going to get the topmost one. As you've seen before, this is what a debug log looks like.
So that's a lot of lines. That's why we built the Apex Replay Debugger, to make it easier for you to actually interact with this.
This is what people are using now. They manually parse through thousands of log lines to figure out what's going on. So the Replay Debugger is going to take this log and make it easier for you to figure out what's going on. Let's see how that is done. I still have a breakpoint enabled from my previous debugging session, specifically in handler find properties. I'm going to use this launch configuration to re-illustrate the issue that we just saw, but this time with the debug log. I can start a session and run to that breakpoint. If you take a look at the variables view, we have this variable utterance with a space at the end. So this is the exact same problem we observed using Apex Interactive Debugger.
So at this point, there's no difference at all using the Interactive Debugger and the Replay Debugger. And this is completely intentional. We want to make this a very seamless experience regardless of which one you're using.
Exactly. With the Replay Debugger, you still have variables on the left side and call stack, and also your debugger controls at the top so you can step through your Apex code. So whichever debugger you use, Replay or Interactive, Nick, the process of debugging will feel natural to you.
Okay, that's good. So we use the Apex Interactive Debugger and the Replay Debugger to solve the same issue right now. It would be more fun if we could actually see the Replay Debugger solving a different bug. So here's another tip and trick for you. You notice that if you find a bug of a particular type or genre, they tend to kind of cluster and exist together. So I'm postulating that if we try another thing that requires white spacing, that we'll hit a different bug. So in this case, I think if we did find house and we put a space after it, we'll also run into the same issue. Jonathan, why don't you give that a try?
That's good insight. Let's try find house with a space. Uh-oh.
So we hit the other bug already for the day. And by the way, I'm not making fun of Dreambot and everything else. This is really an app as we're developing it, so I want you to treat it as how we're doing the lifecycle development. As you're developing, there's sure to be bugs, regardless whether you're using Apex, Visual Force, Lightning, Flow, or everything else. These are logical bugs that come about just from the process of developing software. All right, Jonathan, why don't you show us how you can actually debug this with the Replay Debugger?
Okay, let's see how we can do that. Logging is still active, and since we've just reproduced the scenario, the next thing we want to do is get the most recent debug log. I'm also going to set a breakpoint in this method called find matching handler if possible. And the reason I know this is because this method is responsible for figuring out which handler to use depending on the topic that we provided to Dreambot. So I'll set it at line 61, and I'm going to use this launch configuration that illustrates the find house problem. So it will use the debug log that I just fetched. We'll start a session and run to that breakpoint. After I step over, we can inspect this variable called utterance matcher. You can see that it's a string that says it's a delegate function, which is not very useful. That's a difference between the replay debugger and the interactive debugger. The replay debugger is not capable of showing as much information for now, so we have to help it a little bit. And I'm going to do that with just a couple of lines of code. The first is I'm going to extract a regular expression string from that delegate function. And then I'm also going to use system.debug to print out that regex string. So let's save this code change to the server. And after that's done, we'll go back to Dreambot and run through the scenario again, which is we're going to find a house with a space at the end. Still doesn't know the answer because we haven't fixed the bug yet. But now what this has done is generate a debug log in the background that conveys the problem more clearly. So I'm going to get that debug log. And I'm going to use a launch configuration with that debug log. Now the breakpoint is still at line 61. I'll keep that there so I can start a session and run to that breakpoint. Now a couple things happen here. We have a new variable to inspect. This is now a regular expression string. It's not the one that we want to debug with when we're looking at find house, but it's much better than seeing it's some delegate function. And also, it printed out that regular expression string into this debug console at the bottom. And the best thing about this is it links the debug message to the exact line of code. So for example, I could be browsing other files. I see this get output at the bottom. I can click it, and it takes me straight to that line of code. It's pretty nifty, right?
Yep, I like that feature.
I added that. So we can step over a few times just to see what the flow is. And for this one, it returns null. In fact, I'm going to continue to that breakpoint until I see the pattern that we're looking for, which is this one.
Ah, I see.
This is a regular expression pattern, case insensitive, and it doesn't take into account spaces. So we were able to find the problem pretty quickly with the replay debugger. I think we should fix the problem quickly also and call it a day.
All right. So members of the audience, what should we do first in this case? Should we go ahead and fix the problem? Write a test case, I heard that. All right, Jonathan, the audience has spoken. Go ahead and write a test case.
Okay, I can do that. I'm going to open this test class, and I'm going to cheat a little bit. I'm going to use a template that has my test for me. And this is a very basic test. It just takes the string find house, gives it to the method that we were debugging earlier, and verifies that there is a handler for it. This is the happy test case, so while we're here, we can add a couple more cases. For example, we know there's a problem with spaces, so we'll have one with space. And we also know that it's a case-insensitive search, so we'll have one with uppercases.
Okay, that's a good selection.
We'll push this change to the server, and after that's done, we can run the test. As expected, we have a test failure because we haven't fixed the problem. So let's do that now. We know that these topics are represented as custom objects. So what we're going to need to do is find the custom object for the find house. And inside there is an invocation pattern that we're going to add a .star to so that it accounts for any character before and after. After saving this, we can verify our change in a couple of ways. We can rerun the test we just wrote, and we should see that this test now passes.
All right, that's good.
And we can also use DreamBot to verify that space find house returns a topic that it understands.
All right.
How do you feel about the bug we just crashed, Nick?
I feel much better about it. How does the audience feel? Good? All right. So let me go back to my slides. So what you've seen is the Apex replay debugger that's going to come out in summer. So going back to my slides over here, let's summarize on this. So the big question is, when should you use which one, right? So, of course, first one is the best use case. The best use case for the interactive debugger is live and exploratory. The replay debugger is useful when you do it in after-the-fact fashion. And what I've shown here is one way you can do it. You run it through a scenario, and then you grab the logs and use it. One thing I want to emphasize is that it need not be Jonathan just doing the debugging. It could be me triggering it, and then he can grab the logs, perhaps 24 hours later as part of support, and then replay the whole thing. So this is really, really powerful. The other thing is the availability. We know that the interactive debugger is available in Sandbox and Scratchbox. The replay debugger is available in production, Sandbox, and Scratchbox. All right? So if you need to debug in production, this is your best bet. Of course, the release date matters as well. This is the interactive debugger already G8 in 2017, and the replay debugger will be beta in summer 18 and the G8 in winter 19. Of course, this comes to the most important point for many of you. What's the pricing for this? So we know that you can use the interactive debugger for free for an unlimited and performance edition. It's also available as an add-on if you have a different edition. I know some of you were already at the keynote, so you know the next sale, what the price is actually going to be. But who wants to garner a guess of how much you're actually going to offer for this? $1 million. That's a good guess. With a space. Excellent. It's going to be free. So we want to make sure that all of you have a good debugging experience. You can use this. So at no additional cost, you'll be able to use this. As long as you can generate logs, you can use this. Download the extensions from the Visual Studio Code Marketplace, which will also be free, and go ahead and debug. OK, so let me summarize this. The replay debugger requires a bit of tweaks and changes to the debug log format that's coming in summer 18. Now, if we have tooling partners here, I just want to be very careful. The tweaks that we're adding are additive. We are not going to delete anything. We're not going to change the format. And we can talk more about this after this as well. It's the UX and flow that you see today could change. We are looking to streamline this. This is really in beta form. Of course, if you have any feedback, we would like to hear it from you. So it will be available soon at that URL. And please provide feedback and feature requests at this particular GitHub location. All right, at the end of my presentation, I'm going to give you a summary slide that summarizes all of this, so you can take a picture of that if you want. OK, now let's go on to the summary. So what we've done today is we've gone through the software development lifecycle, and I've shown you how you can actually debug effectively with the tools available. We've seen how we can write code in a testable manner, and I've shown you the features that are available in the Apex code editor to make that easier. Then we've shown you how to use the debuggers, both the interactive and the replay debugger. And of course, we show you, and I hope to instill there, how you can write tests after you fix a particular bug. And throughout the presentation, I sprinkled tidbits of information of recommendations on how you can do it. Get the context right, get a repro step that's reliable, write tests first, think about if you encounter a bug of a particular type, that another one is bound to be there, and of course, have a different set of eyes to verify this. All right? So I want to give a shout out to the people who have worked on the interactive debugger and replay debugger. Most of them are throughout my team, but not all of them are here today at TrailDX. But this is really a very, very big project, and throughout the years, these are all the people who have actually contributed to them. And of course, as promised, these are the other recommended sessions. If you didn't know, Apex is coming out with a switch statement. They had a talk on it earlier. It's recorded, so you can go ahead and see that. If you are interested in using chatbots, what we've shown you is how to build with Apex. There's a new framework coming out of how you can do this much easier with the power of Einstein. So go ahead and check that out. And of course, if you're interested in using the CLI, you can go ahead and go to the creating and using Salesforce CLI plugins. And with that, thank you. And as promised, here's a summary slide in case anyone wants to take a shot of it, of what's going on. All right, with that, thank you very much. Enjoy the rest of Trailhead DX, and if you have any questions, let me know. We'll value any feedback you have on the Apex Replay Debugger. Thank you.